So this is Lesson 5, Course B, Programming with Harvester. The purpose of this lesson is to outline computational thinking concepts, powerful ideas, and critical thinking strategies, to model some pedagogical strategies, and then we'll review those same strategies. In this one, I'm talking about Lesson 5, Programming with Harvester, which is the third lesson that we would like you to cover in the fall. Again, the computational thinking concepts we'll be talking about include sequence and loops, and the powerful ideas include decomposition, pattern recognition, algorithms, and debuggings. Critical thinking skills: observing, predicting, planning, problem solving, looking at cause and effect, and comparing and contrasting. Pedagogical strategies that I will demonstrate today while I go through how to implement these lessons include direct instruction, but also giving students time to play, to think, to code, to experiment with the code in the toolbox, and what happens when we play with that in our workspace, and how that affects what happens in the play space. So kids will be predicting and running, investigating, modifying, and making programs. They'll also be learning to understand what is the problem, to devise solutions, and then to transform those solutions into a language for executing. Next, I'm going to demonstrate some of the lessons within this module. So I'm going to demonstrate Course B, Lesson 5, Programming with Harvester, and you can see that Lesson 1 is a video. I encourage you to watch it. We're actually going to start something new here, so let's look at what is different about programming with Harvester. So let's first observe. I noticed that there's a pick block here, and that pick block is different. I didn't have one of those before. I'm going to plan, and I'm going to plan by decomposing the steps instead of how do I get Harvester to the corn. She's going to take 1 step, 2 steps, 3 steps. Going east. I'm just going to immediately skip to my repeat block because I notice a pattern. 1, 2, 3, that's a loop. I'm going to use my repeat block, and then I'm going to have Harvester pick the corn. Let's hit run. Harvester gets to the corn. Again, we can decompose this by going step by step. If the students are having trouble, I can encourage them to get solutions, to read the directions, to listen to the directions, to read the directions, to show the code. This is my algorithm. We're going to let the students have student-centered learning next, so they're just going to play. And I'm going to skip 2, 3, 4, 5 is actually a video, and it's a video on debugging. Debugging means there is a problem with the program and I need to fix it. I love the idea of debugging because it teaches students that instead of thinking that something is wrong and I'm going to give up, I'm going to notice that something's wrong and then I'm going to fix it. So it's not an obstacle that I can't overcome, it's an obstacle that I just need to figure out. We can debug in computers, but we can also debug in life, right? Let's say that I get up every day and I do my homework, but I forget to turn it in. How can I debug that? Perhaps I should put it in my backpack immediately after I complete it. So I'm going to go to Lesson 6. Do watch the video. I think the videos are amazing on these code.orgs. So we're going to decompose, we're going to debug, we're going to sequence, pattern, and loop. 1, 2, 3, 4, 5. If I look at my algorithm in my workspace, I can see that there's a pattern. I have Harvester going east 5 times. Let me see if I think that's going to work. 1, 2, 3, 4, 5. I'm comparing my algorithm to my play space. I think it's going to work. So I am going to pull this apart. I noticed a pattern. I'm creating a loop. I need to change this. It says 3 times. I like my workspace clean and tidy. I'm going to get rid of this extra code by dragging and dropping it. So Laurel, I think, is going to go, I'm decomposing again, 1, 2, 3, 4, 5, but there's no pick button. So if I want to debug what was already there, I am going to add this pick button. When I run it, Harvester gets to the corn. Again, this is a loop. I saw a pattern, and if I wanted to start over, I would notice that she gets to the corn, but she doesn't pick it. So that was the problem I had to fix. 7, 8, and 9 are very similar to this. So let the students play, walk around. You can let them do some pair programming. But I'm going to go to 10 because 10 is when it gets a little bit different. So what do I think is different about this? There are 2 corns instead of 1. In my workspace, there's no code for me already written, so I'm going to have to create this by myself. I look at my tools though, and I see I have plenty of tools here. So let's come up with my plan. 1, 2, 3. So Laurel's going to have to move, or Harvester's going to move east 3 times. Do I see a pattern there? I do. I'm not going to switch it out yet. Let's see. Harvester is going to pick a corn. 1, 2, 3, pick a corn. Go 1 more space. Pick another corn. Does this work? It does. I'm going to reset it though because I can see that there's a pattern here. So how can I use fewer lines of code? I can use my repeat button. I'm going to put go once. Again, I like a neat and tidy workspace. So when I'm looking at this, when run, I'm going to reset it. I think this is going to work. Can I use another pattern here? I don't think so. If there were another east after the pick, I could use another repeat block, but I'm just going to go step by step, decompose this to see if it works. And it worked great, so I created a nice algorithm. I'm going to continue on to the next one. I'm going to skip. Again, we're going to let students have student-centered time. You can see they get progressively a little bit more complex. This one has 3 ears of corn, but there's also a turn where our harvester has to change directions. But let's go to 12. One of the things I really love is when I get to the challenge puzzles, and you always want to encourage kids to do the challenge puzzle. Again, why does this look more challenging? I'm not sure. So let's see what I can think. I see more ears of corn. I see more turns. I see a repeat button here. A repeat button indicates a loop, so I'm going to look for patterns. So let's do my plan. I'm going to plan 1 step. Pick a corn, don't forget your pick button. Then harvester is going to turn north. And she's going to pick another piece of corn. This is my algorithm. It looks like it's coming along pretty well so far. If the kids are a little uncertain about what they're doing, and that would be normal at this time, do a demo, right? It doesn't really hurt. Let's see, is the code that we have written so far correct? Sometimes it's easier to correct the bugs, to find and correct the bugs early rather than later. Okay, so I'm getting where I'm going, but I didn't finish. So let's see. I think harvester has to go east, pick another piece of corn. I think she has to go north, and she has to pick another piece of corn. I'm just going to hit run this time. Alright, I'm going to try this again though. I don't want to zip right through this because I'm looking at my algorithm. I'm going to look for patterns. Do I see, this is my sequence. I'm going to look at my sequence and I'm going to see if I see a pattern. I see east pick, north pick, and then look, east pick, north pick. So this is a little bit more complex of a pattern than what I've seen before. Compare and contrast. Why is it more complex? Because it has 3 different blocks. Typically when I've seen patterns in the past, it's just been east, 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 and those have been sort of easy to see. But this is a more complex pattern. I'm going to use my repeat button. I see that these 2 lines of code, let's compare, east, pick, north, pick. They're the same. I can put this whole in there. It's going to repeat twice. Maybe I want to leave this in my workspace until after I run it. Remember, if it's not connected, it's not going to get read. So let me reset. Let me hit run. Nice. nice. I'm going to say try again only because I want to clean up my workspace and I want to make sure that I don't leave any unused blocks there. So again, for numbers 13, 14, and 15, let the students play, provide your direct instruction, and next I'm going to debrief. We created a sequence that was a list of steps to get Harvester from where she was going and helping her to pick up all of the corn. While doing that, we saw some patterns happening. We recognized those patterns and we created loops using the repeat button. We decomposed. Sometimes we just hit run and we took Harvester through the maze, but other times we did it step by step. And we created an algorithm, and whenever we ran into problems, we debugged those problems. Critical thinking, we observed what was happening, we predicted whether or not Harvest was going to get the corn, we made a plan to get Harvest all of the corn, and we solved problems when they came. Cause and effect, what happened when I pressed the button, what happened when I put a pick corn button and when I didn't pick a corn button, what happens when I press run, what happens when I hit step by step. That's also comparing and contrasting, right? How are these mazes the similar? How are these mazes different? You can even ask, how is what we did with Harvester the same as what we did with Angry Bird? How is what we did with Harvester different from what we did with Angry Bird? And we used different pedagogical strategies. So it wasn't just direct instruction, but at the same time, it wasn't all play. We gave some direct formative instruction and we guided students while they investigated and modified and made things and solved problems to write an algorithm and to turn that algorithm into a successful program.